Hey, welcome to Civil Tech. I hope you will enjoy this video. Please don't forget to subscribe and share. Also like, please. Let's start. So guys, today's video is frame. Okay. What is frame? The building consisting the frame, various types of frame, not trust. Upper portion, down portion, anywhere. The frame is the most important structure for a building or any structure now. So frame at two methods. We are applying two methods. Sway frame 1, without sway. Number 2, with sway. Sway and without sway means what? Changing position, deflecting. Suppose this is our frame. Suppose this is our frame now. Because of external load, suppose we are applying load here external. Okay, if we are applying load here external, the frame will be deflect like this way, changing their position. Okay, or this side. This is called sway frame. Sway means deflecting, changing position. And non-sway, without sway, means it will be as it is, no changes. No, if there is load applying, external load also, no changes because of some fixed moment, fixed support. Okay, so today's our numerical is without sway. And this is example. Frame with sway. No, this is without sway, means not position, changing position. See here this figure. Load containing 3 kilonewton. Here from this side 5 kilonewton, from that side 10 kilonewton. It's not moving at all, this side or this side, because the load almost similar, not different so much. And this fixed in moment, there is fixed in there, that's why not deflating here position or here calculating. So as usual, our first step, second step, third, fourth, fifth, sixth, we already done this calculation in the last two videos, whatever we did now. So it's better to see this also. I've already given this formula, all formulas and details. I have explained details in these videos. Now I will just saying the concept, how to do this frame now, to clarify. Okay, see, note down this figure first, then first step, FEM's calculation. You can, if you feel confusing, to imagine this diagram. This diagram is nothing like this only. Here one support 3 kilonewton, here 5 kilonewton, 10 kilonewton. You just imagine, I'm just giving example here is a beam. This, if you folding this like this, it will be frame like this way. Now this distance 2 meter, 2 meter, 3 meter, not 4 meter. Okay, so for this portion, point load is there, point load. So we are applying this formula, minus PL by L, MF AB, MF BC. Similarly, plus minus formulas same, 2.5 correspond BC, WL because of UDL. No, yes, UDL correspond CD, PL point load. Getting this answer. Step 2, slope deflection equation. We know this equation are deriving from the slope deflection method. These all are formulas are getting by deriving this equation, slope deflection method. Now I have already told this. Just put the value. I'm just clarifying here. concept, the basic concept of frame and beams, and backy calculation remaining all are same. This MFAB, MABC, MCB, MCD, all calculation same. MDC. Step 3, calculating equilibrium condition with calculated slope rotation. Taking moment about point V. At point joint P. Here we have to find a moment at point G and C. There is not any rotation, no? Point A and D. Point B and C is something will be rotation if that load it is applying this side. How much? The little bit. We have to find only this. Okay. To find this rotation, we have to apply the equilibrium condition at these joints. From joint B, M of AB, summation of B, MBA, MBC. Now, wait. This is our figure. A, B, C, D. So here it will be like this now. You will see from this MAB from this side now. MAB from this side to this side MBA. Okay, similarly here MBC, MCB, similarly here MCD, MDC. Okay, F1G, B, MBA and MBC. Adding this, calculating, we're getting here some values. Equation number 7. Okay, don't understand. MAB means this is MAB, finding it here, and MBC, this equation. If you add this equation, we'll get this equation. We call it 7 number equation for point C. MCB plus MCD at this point. MCB and MCD. If we adding this both equation, we'll get one equation. This is called equation number 7. Okay. So now 7 and 8, whatever we're getting this equation to, we're just calculating and we'll finding the value of theta B and theta C. Okay, so how to calculate this theta B and theta C values? Just nothing. Equation 7 and 8 now. Just put the value in the calc C. Okay, how to find this in calc C step. This scientific calculation. Yeah, I hope you have this calculator. So step 1, first step in click mode button, in equation number 5, put in the 5 equation. Then see here how many digit or step. Here 1, this is 1B, C and D. ABC, okay, 3 parts is there. So consider this equation number 1 step, right? Then put the value first 2, click OK. Then how much is this? Half, no, 0.5, then 1.5. The next equation for this equation number 7, this is 0.5, 2, then 1. Okay, just click equal, you will get easily how much? 0.6. See here, theta B equal to 0.6 by A. You can write this also, this way also, theta b ei equal to 0.6. okay, similarly theta c equal to, get this last calculation moment. This is the last calculation and final answer, final ending moment, final answer. We're getting this theta b and theta c value. Put these two values as the equation, solve deflection equation. Put there theta a and theta b. How much? Theta b and theta c. Here theta b, this value will be 0. Just this two value put in all equation, will get it this way. MAV equal to minus 2.17, MCB, MBC, vice versa. What about this now? We're finding this way. For spin moment, means free moment diagram now. Here, see, once again, for this containing load, point load, this is Udl load. There is some will be moment, the diagram will be there now. Because of this, we have to apply the different formulas. I have already given this formula and told about this. Udl for Udl and for point load, the different formulas is there. So according to our figures, this is Udl, this point load, this is 10, this 5, this is 3. No? For Udl, we have this formula. M equal to, for spin AV, PL by 4. PL means what? P5 into length, total length. One second. P load into length, total 4 meter. 2 into 2 now. PL by 4, equation 4. I'm finding you're getting this 5 kilonewton. For spin, this BC. For spin BC, M equal to WL square by 8. Because of UDL, this formula will be changing. WL square by 8. 3 into 4 square, L square by 8. We're getting answer for spin M. CV also 10. Okay. Now, how to draw this BMD, bending moment diagram? Okay, it's very easy. Just concentrate here. See this, I have already told. If you selecting as a beam, considering, just imagine you're considering as a beam now, it will be like this now. A, B, C, D. So first MAV, I'm showing here MAV, how much? MAV minus 2.7, because of minus anti-clockwise 2.17. MBA 3.16. 3.16, 2.17 minus 3.16. This all value are same. Both here also similar values. I have to show here. It will be better. 2.17, 3.16. This is how much? 4.6, 4.66, and this is 5.16. Okay, now see, from that point now it's anti-clockwise. It's anti-clockwise, it's rotating this way now. from that point, rotating this way anti-clockwise. So it will be hitting here upward side. The beam will be coming on the outside. Okay, 2.7. Here also 3.16. It will hitting on that point. Means it will also come outside. 3.16. Just to join it. Similarly here also 4 outside, it will be outside. 5 little much bigger. Okay, then there are 3 outside, this 3, this is 4. Because of the point load, because of this point load 5 kN, here will be figure 1, free moment. We already calculate this value 5, 6, 10. This value will be 5. Okay, because of the Udl, this diagram will be like this. Okay, how much is this value? 6. This point load like this. This 10. Now just mark this as positive. This is. It's very simple. Okay, I hope you understand it. See here, as it is ABCD. So lastly, to drawing SFD shear force diagram, this is our figure. Okay, first calculating the reaction on this figure. So we have loaded this figure. Suppose I'm showing here, this is a frame now. 1 second. There we have to assume in the reaction at this point array, and there is also developing horizontal because of this load in this direction. HA here array, because of this direction the load is applying this direction now. That's why the horizontal at this point HD will develop here, and here also RD. Okay, this figure like that now. So how are we calculating this reaction? We have to find the reaction at point B and point C. Rotation, that means now. To finding rotation, we have to taking moment at point B and point C. So let's see, let's see whatever. What is this? First point B, considering here reaction, taking moment at point B, considering on that portion only, this side. Okay, if we considering here for moment with respect to V, so this 4 meter distance now. This rotating, see here, this rotating, if it's see here, it will rotating clockwise direction. It will rotating that way. So its reaction will be horizontal. So moment, how to calculate moment? Perpendicular distance into load. No, load into perpendicular distance. Load means reaction here, this HA into perpendicular distance. Similarly here this also, but here this is rotating anti-clockwise direction with respect to B. This way it will be negative. So see here, also 2 moment will be here, MAB and MBA. Okay, so it is how much it will be the equation. See here, HA into 4 minus 5 into 2 plus HM equation. Now we're getting here horizontal reaction. The value of HA we're getting here. Okay, now with respect to point C, moment, how to get it here? This plus this will have similarly RV. We find here the value of RV, reaction at that point. RV, we're finding here the rotation, that means this is rotation. Okay, Similarly, point C, we calculating this side to find this value. Now to finding C value, we have to calculate from this side to this up to this. We're getting the value of C. Okay. Similarly, getting with respect to point C, we're taking the moment about point C with respect point D with respect to point C. C and D. This is moving anti-clockwise with respect to C, right? So this is why it will be negative. This force total distance how much? 4. No, HD C here. This point here C here minus HD into 4 plus 10. It is moving clockwise direction into 2. No, 10 into 2 minus the moment also MCD MDC. Now getting here is the value of SD. For this, now calculating with respect to V again. Moment, taking moment about the V. We're getting RD now. This RD, how much? This is here, means it will rotating anti-clockwise with respect to this. See here. No, not this point. This RC here, no. RC, yeah. RC rotating here. RC into 4 minus RC into 4 into 3 into 3 means this value. So what is the value? While you calculating Udl moment for moment, no? Our formula is that ml into L by 2. That means what? Moment means ml means ml not. This is W, yeah, WL means UDL load into length into L by 2. This is our formula for moment. Okay, here also same. So 3 our UDL load W into length 4 into 4 by 2 L. Okay, plus this MBC MCB. So that we get here value of reaction of RC. Okay, now we finding here everything, all values. Now we have to draw. For drawing this diagram, see reaction, we have RI value, not RA, this is HA value, how much? 2.25 HA, RB 5.62, RC 6.3237, HD equal to 4.37. okay, this is our value. So figure, our figure is this one. For understanding, I am showing here. This is AC means this value, almost 2.5, 2.25. So 2.25 see here. It's going positive, no? It's going upward side, 2.25. Then this 5. Here 5, no? Udl, and here 10. 5, 3. So for this portion, this 5 coming here, have to fight 5, no, loads. Then it will going downside. How much? 2.25. Remaining portion 2.75 now. Remaining is coming downside 2.7. See it, 2.75 kilonewton. Then connect it to the direct. That's next line. Similarly, here for this position, this point, how much? 5.62. So 5.62, it will upward positive, no? 5.62 and 6.7 because of UDL. Because of this UDL, it coming downward side. Okay, 5.6 and this is 6.2. See here, because of UDL, it's coming downside. Suppose example, if it is point load, if there is point load now, then it will not coming downside, it will be like that. Okay, just clearing concept. Similarly here, this positive here, that side, positive now coming outside, and that points 4.8 going down, then till 10 it will be down, then connect to the next point. See here, 4.7 up, then till down 10, next how much, 10 minus 4.37, this, then connect to the next one. This is SFD, share force diagram. The character drew like that. This is finished. Inside force is negative, downward portion means negative, this downward portion means negative. Okay, this negative downward portion, that's all. Similarly for another frames, I'm just showing, this is for overhanging, its formula. For these two loads, equal load with equal distance, the formula is will be like that. For understanding, I'm showing here. This will be formula. Okay, thank you. There is so many problems, and there are 2, 3, 4, 5, 6, so many numericals, different types. But yeah, you should visit that given website on the given link and check out the other numericals, similar related numericals for your practice. You can see there. Okay, all right. Also, if you want similar type of numericals, similar means also different structure figures, you can visit the website, link is given below, 7e and 21.blogspot.com. So thank you.